Hello and thank you for watching this Module 9. Now we are going to be looking at this topic called hypothesis testing. Now this topic can be a very broad, very long, drawn-out topic. So we're going to split it down into a few different modules of different types of tests that we can do. This module will probably be the longest of the next few modules that we're going to be looking at, because we're going to go through just what is hypothesis testing and what are we doing. Basically what it is that we have a claim, we have a statement about some unknown parameter. In Module 9, that parameter that is unknown that we are going to be testing is going to be a single population mean. Now, what do I mean by some statement? Well, we'll have actually competing statements and three varieties of it. We'll have what is called the null and the alternative hypotheses, and these now are going to be competing claims about the value of the unknown population parameter. So for example, I'll be testing, let's see that the unknown population mean mu, is it greater than or equal to some hypothesized value? So this is some value that I think it might be, or that I think it might not be. So I can test, is it smaller than that hypothesized value? Or I can test to see, is it equal to some hypothesized value? Or I can test to see, is it larger than some hypothesized value? So here we have what are called the lower tail test, two-tailed test, and an upper-tailed test. So we have competing claims about the value of some unknown population parameter. So what this means is that, well, here's my population. All of my observations exist within this population. And let's say for now, let's start off and assume that we know what the population standard deviation is. So I know the population standard deviation here is sigma squared. What I don't know is what is the mean of that distribution? What is the average of that population? And so that's what we are going to try to determine. And so these hypothesized values here would be some assumption or some goal or some value that we want it to be, or maybe some value that we're testing to see if we've managed to change. Have we increased the population mean? Have we decreased the population mean by taking some action on that population? So what we're going to be doing is taking then a sample from this unknown population and determining whether or not the information contained in that sample supports either the statements given in the null hypotheses or the statements given in the alternative hypotheses. So do I have evidence to support that the null hypothesis is true, or do I have evidence to support that the alternative hypotheses are true? And these are always just two competing statements. So how does this all work? Well, we start off, first of all, our tests are always going to be done using a normal distribution. So here we'll have this normal distribution, and it's very helpful if at this very early stage of this discussion, we keep in mind that any time we are performing a test, we always operate under the assumption that the null hypothesis is true. The null is true, whatever we have said in that null hypothesis is true, unless I have evidence that shows otherwise. So if the null hypothesis is true, so I assume it's true with whatever is that hypothesized value. Now, what we do is we take a sample. Of course, that sample could be here, and that might be the sample mean. Maybe my sample is here, and there's my sample mean. Maybe it's here, there's my sample mean. Maybe it's here, right? We know that there's a sampling distribution. So if this population distribution is distributed sigma naught, whatever value that takes, well then I know that the standard error, or the distribution of these possible sample means, well, that is calculated by sigma naught over the square root of whatever our sample size was. Okay, and these if these formulas that I'm using here, if they seem a little fuzzy and you don't remember where they come from, then we can go back to previous modules where those are first introduced. So this tells me what is the variation in possible sample means from this distribution. So in order to perform the test, we make some claim, some statement about the value of that population mean, and then I want to see, does the sample provide me with evidence to support it or refute it? So what we do is we take a sample, and let's say our first sample that we take is this one here, this X bar. This is our sample. Now, I want to determine what is the probability that if that null hypothesis is true, which is our big assumption here, if that null hypothesis is true, what's the probability of obtaining a test statistic similar to this one that we've actually obtained? Is this an outcome that is very likely, that is very probable to come out of that distribution? Or, given that assumption, is it very unlikely to have obtained a sample with a mean such as this one from that distribution? So that is what gives us, when I say evidence in favor of the null or in favor of the alternative, that's what I'm talking about, is does this mean, under this assumption that the null is true, is that mean very surprising? Is it really rare? Are we shocked that how could we get a mean like that from that distribution? If that mean occurs with very, very small probability, then that gives us evidence that, well, the null might not be true then, if it's very unlikely that this mean came from that distribution. That's what gives us evidence against the null. If it's very likely, high probability of obtaining that sample mean from that distribution, well, then that gives us evidence that supports the null. So what we're going to do, we'll have our second distribution here, another one that you're familiar with. This is our standard normal distribution. And so what we'll be doing now is standardizing this value using this formula, very similar to one that we've seen before, only now we're dividing by the standard error instead of the standard deviation. I think maybe module 5 or 6 we looked at that. So now any sample mean that we take from this distribution, we can standardize it and find the corresponding value in the standard normal distribution. So now we have a z-score. And then we'll be using the z tables, and we'll also be looking at the t-distribution as well in this module. We'll use our probability tables, and we'll determine what is called a p-value, which in this example, I'll call this my p-value. Here I'm sort of implicitly doing what would be an upper tail test here. So what this means then, oops, what happened here? So what this implies, or what this tells us, is our probability of obtaining a test statistic at least as unlikely or as rare as the one that we've obtained. So if we calculate this probability in this upper tail here, for this example of an upper tail test that I'm working with, that tells me is that sample mean, which corresponds to that test statistic, is it very rare? Is it very unlikely to have come from this assumed distribution? Or is it no surprise that it's very probable to have come from that distribution? So if that p-value, or that probability that corresponds with our test statistic, if that p-value is very, very small, that means that the null hypothesis might be true, but to obtain a test statistic like that one might be extremely small probability to obtain a test statistic like that one from a distribution that corresponds with our null hypothesis. So if that probability is so small, that is what tells us that, well, it probably came from a different distribution, not the one that we're assuming that it is. And so we have some different rules that will apply in order to determine whether or not I'm going to support the null or support the alternative. And so what we'll say is I do not reject the null hypothesis if my evidence supports that. In other words, if that probability that corresponds with my test statistic, if that probability is very high, that means that it's very likely that it came from that distribution. So that means my evidence supports the null hypothesis. If that probability that corresponds with my test statistic is very small, that means that it's very unlikely that that sample is coming from that distribution, and that supports the alternative. So then we would say, well, I reject the null hypothesis because it's so unlikely that this value came from that distribution. So we'll go through a few different tests like this. We'll start off looking in Module 9 here. We'll be looking only at single population means and single population proportions. We'll also have a little bit of a talk on the difference between type 1 and type 2 error. A type 1 error is that I reject a true null. So maybe the null hypothesis actually is true, and I won't know this. If we knew it, we wouldn't have to do the test. But maybe the null is true, but my evidence caused me to reject it anyways, so we can commit a type 1 error. Or a type 2 error is if I accept a false null. So what that means is that the null hypothesis is actually wrong, the alternative hypothesis is true, but my evidence causes me to incorrectly accept the null hypothesis. So that's hypothesis testing in 11-minute and 37-second nutshell. We'll go through a few exercises now, and we'll just kind of go through the procedure step by step, and hopefully the practice, it'll come very naturally because the procedure is the same no matter what kind of test it is that we're doing. So thank you very much for watching. I hope this is very helpful. Okay, let's get started. Bye-bye.